Hello, my name is Roland Wolters and I'm Technical Marketing Manager for Ansible Security Automation. I will be your host for today's demo. Before we start, I'd like to quickly talk about the challenges we are facing in security automation from a technical perspective. Basically, it comes down to two elements. First, timing, and second, errors. Let's speak about the timing piece for a second. In the end, if you're using security tools today, you have multiple vendors, multiple products. That means if you're hunting a threat, if you try to figure out what's going on in your environment, what you need to do is you need to talk to all these, which means basically clicking through graphical user interfaces. And this means with multiple vendors and multiple products to click through a lot of graphical user interfaces just to gain rather simple information. Or imagine you want to increase the verbosity logging across your landscape. That means changing one single piece of configuration in multiple pieces. To reach this single information, this single config element, you usually have to do multiple clicks through multiple levels of the graphical user interface. This all costs time. And if something suspicious is happening in your environment, if you're hunting a threat, time is crucial. Usually you can't afford to waste time clicking through a lot of things. And as I said, it's not only about timing, it's also about errors. So if you do all these changes, all this hunting, all this, let's say, logging verbosity increase, if you do this all manually, it's error prone. You will make mistakes. You might make errors, things you didn't want to. You might overlook things, and so on. And this is also serious because if you are in a critical situation, the last thing you want to do is making errors, probably missing important information. And for both of these challenges, timing and errors, automation can be a crucial factor to mitigate those. So let's start. In our situation, we will now imagine that we are a security analyst in an enterprise. And as this security analyst, we were just informed of something going on in an application. We are not entirely sure what this is, so as a security analyst, we first hop onto the system and check out what's going on. Here I have an editor, and right in my editor I have a terminal. We use the terminal to access the target machine. And here on the target machine, I check out the logs of the application. And we wait a few seconds. We see already a couple of suspicious logs. But as you see, the longer we wait, new logs appear. So something is indeed going on. As a security analyst, we know that anomalies can be the sign of a breach or other security causes. So, as a security analyst now, we decide to investigate. Just these log files, of course, is not enough information about the anomaly to figure out if this is something serious or something we can basically just dismiss as a false positive. So our next step is we need to collect more data points. For example, from a firewall or from an IDS. Of course, as already mentioned, going through all these logs manually requires quite some time. So best is to feed the logs into a tool where we can actually correlate them, so-called SIEM. So in the end, what we need to do is we need to be able to first access the logs, get them, and feed them into the SIEM. All this requires quite a lot of interaction with other teams, with other people, with other tools, and so on. And as already mentioned, this is a huge problem in terms of timing, in terms of efficiency and error prone, and it is just very cumbersome to click through multiple GUIs. So we use the automation to deal with it. First, as mentioned, we look at it from the perspective of a theme. In our case, in our demo environment, our theme is Curator. Second, we need to get the logs in here. I'd like to interrupt here for a second. The question is, why don't we feed all the logs into the theme all the time anyway? I mean, we have the theme, we sometimes need the logs, let's connect them. Then we don't have the challenge to connect them only when we need them. There is a catch. The problem is, first and foremost, imagine you set all your firewalls, all your routers, all your servers, basically any system in your environment, all the systems, to verbose logging and send those logs out. You might saturate your bandwidth here, but even if bandwidth is not a problem, even if the performance of all the log generating systems is not a problem, your theme at some point will start to be a bottleneck. And even if the theme itself is powerful to just take all the logs in and write them away, your searches you perform and the analysis you perform in the theme will come up with results you don't need because you feed so many logs in. So at some point with all the logs, you might miss the important bits, the important security-related bits in all the traffic noise and all the log noise. Not to mention that some of these solutions are actually paid by the log number. And for an efficient environment and efficient running of these systems, you probably only want to feed those information in which you really need. So, what are we going to do? We are going to feed the logs into the system just the moment when we need them. And as mentioned, to avoid the need to reach out to other teams, talk to them, get them to send us the logs, we are going to do this automatically with a script, with a playbook technically. So, let's see. This is the playbook we wrote for this. First, we are speaking to our Snort system, to our IDS. We will configure it to send the logs to an external system, here to our Curator instance. As you see, this playbook, or this play in the playbook, is rather short. We only define a few variables and then call it. What you see in the background is we're using a role, a pre-configured set of playbooks here to manage all the configuration which is needed on the IDS of our choice. This makes it, of course, very easy to handle the IDS for people who are not specialized on this topic, who are not domain experts. All people need to know is basically the IP address where they want to send it to, the log protocol, UDP or TCP, and what IDS they are actually talking to. And that's it. They don't have to think about or have to know how is the IDS configured, how do I restart it, do I have to restart it, where do I put the configuration for external logging and so on. So with this play, we already reconfigure Snort to send logs to our external IP. However, Curator of course needs to know that logs are coming now to properly sort them and understand them. And for this we have another play starting here to add the Snort log into Curator. And as you see, this is also rather short. But instead of a role here, we use a collection. So what is a collection anyway? Imagine you start writing your Ansible playbook. You put all the tasks in there, and at some point you realize you have to provide a config file, and you reference it in your playbook. You put the config file somewhere, and then you maybe write a specific connection plugin or even your own module. You need to put it somewhere. Then you want to make this reusable and provide it to others. How do we package all these data? How do we bring it together in a consumable format? How do we version it? And this is exactly where collections come in. Collections are a way to package basically Ansible content. They are very often used to package modules, connection plugins, but can also contain playbooks, roles, and similar things. And all this can be brought together in one bundle and be handed over to the basically consumers of the collection, often the customers or your other team members or people on the other side of your IT environment, of your IT team. And given the collection, we can use a module inside the collection, which is reconfiguring Curator to accept these log sources. Again, we don't need to be a domain expert of Curator to be able to do this. We just use some parameters and that's it. And of course, there's no Python or other heavy lifting involved. We don't need to be able to program. Next, well, we do have a firewall. Let's use the logs of the firewall. And it's two steps again. First, we reconfigure the firewall to actually send the logs to our Curator. And second, we tell Curator to accept the logs. The first stop, where we first play, where we reconfigure checkpoint to send the logs to Curator, takes advantage of a role again from the Ansible security team, which helps us to quickly reconfigure our firewall to send the logs to a given syslog server. And this part you basically already know is where we tell Curator to accept now the logs from checkpoint. Last, I like to highlight this play part. In the end, with a theme, you usually collect a set of configurations before you deploy them. So the last task we execute is actually telling Curator, now deploy the configuration, now make the configuration live. So this is our playbook. Let's see what happens when we execute it. I bring up my terminal again. This is the playbook, so the command is Ansible-playbook. The parameter is the playbook itself. What you now see here is Ansible going through all the different steps, through all the different plays we have shown above, and executing all the necessary tasks in there. You see where also things were changed, like I scroll up here, adds not remote login to Curator. This was not the case before, so a change happened and Ansible indicates the change as such. The same is true down here, and we are already at the latest part, where we are deploying the actual new configuration to Curator. And there we have logs coming already in. You see here the checkpoint firewall message. Let's add the filters. We take indexed log sources, so where we can actually pick a set of defined log sources and activate them. And I take snort and checkpoint as the log sources, so I only see logs coming from those. So, question is still, how can I verify that these log sources were properly configured? At least I get something from checkpoint here, so it should be fairly clear that I configured my log sources properly. However, let's look into this system. We take our terminal and log onto this system. So we are now on the firewall machine, and the best way to check if we configured the log source here properly is to go into the right directory where log exporters are shown. And we have a target here, we have the target directory here. Oops. Didn't switch into the directory as I thought I would do. Here. Here you see in this directory already the syslog configuration. And so we know the central log server is configured. So let's also quickly verify this on Snort. At least the name resolution works. We quickly become root. And as such, check the typical syslog configuration. And as you see, here's the IP address and the target port of the curator as well. Good. So, however, if we now look at our curator log activity, we don't see Snort here. We only see checkpoint. Why? Because right now the IDS doesn't really know what to look for. So the very next step is we need to configure Snort and the appropriate Snort rule to actually look for the suspicious traffic we have. If you remember, we had traffic going on an Apache server calling a specific URL which was suspicious for us. So let's deploy a rule looking exactly for this. And of course, to deploy a new rule in Snort, you first would have to call the IDS team, talk to them, explain the rule to them, and let them deploy it. Or you would have to do it yourself, but then you would need to understand how the inner workings of the IDS are, how to deploy a rule, how to restart the system, and so on. With Ansible, it's way easier. And, sorry, before I forget this, IDS usually runs on multiple systems, so you would have to do this across a large amount of systems. With Ansible, this is fairly easy because you can easily talk to many machines. And Snort is well supported in the way that we have a role, like shown here, where we can configure new roles. You still need to know how a rule looks like though. So in this rule, we define an alert, define the protocol, which is basically a variable coming from here, source IP, source port, and we just collect everything. Same as for destination IP, destination port. Then we define the message which should be shown in the logs and what content to look for, the web attack simulation. And since we have all this already, I'm going to launch another Ansible playbook, run, where we do execute this playbook. Again, here we have changes. Interesting enough here is there was a handler which was run, an Ansible handler, which restarted Snort. So the role automatically identified that Snort, that this config change we did is something where Snort needs to be rebooted. The domain knowledge about the target system which is configured is moved into the role. The person executing the playbook and even providing the rule doesn't have to understand the inner workings of the IDS. So let's have a look at our log activity in Curator. And as you see immediately, we have a lot of Snort logs coming in. And those generate offenses. Let's check out the offenses. Indeed, we have one here. The next step in a real environment would now be to check if the source machine is an internal or an external one. And if it's an internal one, if this behavior is wanted. For the purpose of the demo, we now assume that this is an internal machine and the team of the machine provides the feedback that this behavior is indeed wanted. So this is a false positive. And that's exactly what we are going to do now. We mark this offense as closed and as a reason pick false positive. So last but not least, we are done now. We understand what happened. We followed up on everything. We reconfigured the systems to collect enough information, which means that we have still all the logs coming into the main system. And this brings us to a topic of rollback. We should do rollback. So let's do this. For rollback, we use a playbook which is very similar to the original log sources playbook. If we look at the log sources playbook, the differences are only in the parameters. Here, for example, we define that the remote log in snort should be true, while in rollback we set it to false. And in the one playbook where we add snort logging source to curator, the state is present, and in the rollback playbook, the state is absent. So we reuse the code we have in a different playbook to simply set all the systems back to the original state. Let's execute the rollback playbook. As you see, a lot of tasks changed, so things are actually done. And at the end, again, we deploy the log source changes to curator and are done. So let's start. You're a security operator in charge of an enterprise firewall in a large corporation. You just found out that a policy enforced by a checkpoint next generation firewall protecting your line of business applications has been repeatedly violated. Let's have a look at this. This is the interface of our next generation checkpoint firewall. And as you see, there's traffic coming in which is dropped. We should better look at this, because the question is, what is behind this? In the end, this could be the outcome of an attack. The best way to investigate is now to correlate the firewall logs with logs generated by other security solutions deployed in our network, like Snort. And we correlate these logs, in best case, in a theme, like Curator. However, in large enterprise environments, usually security solutions are not integrated with each other. Different teams are in charge of different aspects of IT security, processes in between are missing, and so on. So in our scenario, the typical way for a security operator would be to escalate the issue, to contact security analysis teams, manually sending them firewall logs, and so on. However, it would be way better if we could automate this with Ansible. This is easily possible because with Ansible, via the Ansible playbooks, we can talk directly to a lot of pieces. Let's quickly talk about Ansible playbooks. With Ansible playbooks, you can bring together multiple people to work on one code of automation. However, this brings in another new challenge, because each and everyone working on this playbook, on this common playbook, has to provide their credentials into the playbook. So suddenly, everyone has to bring in their credentials, has to give away the power, the control over their respective domain. This will lead to the weird situation that people are willing to take part in the automation, but are not willing to actually write the code because they don't want to give away this control. How do we get them together nevertheless in one single layer of automation? The answer here is governance. We do need one system which ensures that only people have access to the automation who are allowed to access it. And we also need a system which enables us to enforce governance so that credentials are kept secure, that the access to the automation and the right to execute automation is separated from the access rights to the credentials of the corresponding system. And yes, here we are talking about Ansible Tower. In Ansible Tower, we have the capability to do exactly this. We can have a library of pre-configured playbooks, security playbooks, doing various things on the security endpoints, and with the help of the inbuilt role-based access control, we can provide these playbooks, these here job templates, to other teams as they need. Let's try this out. Keep this view in mind. This is the full library of all our job templates because we're the admin user. So we log out and log in as the user ops firewall. Password. Check, yes. So, let's check which templates the firewall operations team can see. Few things to note. We have the blacklist attacker, we have the send firewall logs to curator, and for later we have the whitelist attacker. What we can do here is now we can blacklist and whitelist things, and we can send firewall logs to curator. These are playbooks we usually maintain and we can use, so we can also edit them or we can even delete them. For the current situation, we know we are possibly, or we see logs which are a problem, so we decide to send these logs to curator. We execute the job to send the firewall logs to curator. However, the team still needs to accept the logs and sort them into the proper streams. So let's log out and log in as someone from the analyst team. As the analyst team, we do have control over the job templates or over jobs to accept firewall logs into curator and to accept IDPS logs into curator. We can do this the moment we need it. Also, if you're paying attention, here are two more jobs we will later on speak about, which we can't change. We don't have the right to delete them. We can just execute them. But later, more about that. First, let's accept the firewall logs into curator. If you're familiar with Ansible Tower, what's happening now is, as in the previous situation, we jumped into the actual jobs overview where we can follow the execution of the Ansible playbook. On the left side, you see a lot of details, like the state, it's currently still running, when it was started, if it's finished or not, which job template was used, and so on. This, in the end, is important for auditing. Here you also see who ran it, when, and so on. So later, if you have a security audit or want to follow up on something which was previously executed, you have all these information available. And they are stored in the database and can, of course, be exported to other environments. So, we are done now. The new security configuration is deployed. And one thing here, in the background, a lot of tasks happened already automatically. For example, to execute these playbooks, we had to use a collection. On this environment, the collection was automatically installed by Tower because Tower saw that it was needed. Have a look at the jobs themselves. We see the recent executed job. Note here that we do not see the job of the ops firewall team. We can only see the jobs which we executed or we have rights on. So let's quickly verify the new configuration. We jump into our scene, curator here, check the log activity, takes a few seconds. There we need to filter on the log source. And let's see. So we filter all incoming logs to checkpoint firewall messages, and as you see, they're coming up here now. So the configuration worked. To quickly verify that this really works and that we created a new log source, quickly look into the admin part of Curator where we can access the log sources. And indeed, this log source was added. So, to decide now if this violation is a false positive, we need to make sure that other sources are not seeing this attack. So the firewall currently is blocking this singular thing off. But our IT environment is larger. It's not just one target machine and one firewall. We have, imagine in a corporate environment, you have hundreds, thousands of servers. So next is we hunt. We check other machines for the very same threat. And in this part, for the purpose of our demo, we now want to deploy an IDPS rule across our environment to see if this same problem is popping up anywhere else. We could go into this code, write an Ansible playbook about this and execute it, or as the ops team, we have prepared for something for this. So let's log in as our ops IDS team. The IDPS operators in charge. We navigate again to the templates and look at what templates do we have currently. So one is send IDPS logs to Curator, makes sense, so that we enable our IDPS, in this case our snorts, to send the logs to Curator if something pops up. And there's another one, add IDPS rule. And this one is special because it has a survey. Here we query to input a snort compatible rule. What does it mean? If we execute it, we get an input field for our snort compatible rule. Still, snort rules do require some bit of knowledge about snort rules. They can become quite lengthy, so I copied an example here. We paste it in. We click on Next, we launch it, and immediately we are brought to the job view where we can see what's happening. While this is finishing, another question comes up. Of course, we do have to send the logs to Curator. Well, we are the IDS ops team, we are in charge of this, so we have a template for this, job template, so we could just execute it. However, in the end, if IDPS logs are sent to Curator or not is not that interesting for the ops team, for the IDPS ops team, but it's way more interesting for the Curator team. So how about we provide the execution rights for this one to the analyst team. Let's have a look at this. We log back in as the analyst. And here we have the very same playbook, send IDPS logs to curator. However, we can't delete the template and we have no write rule. Rights. We can only execute it. Do it. And another thing we also need to execute in the background is we need to accept the IDPS logs in curator, because so far it only accepts the firewall logs. So we execute this as well, and since we have multiple jobs now running, we go into the jobs overview and wait for them. One thing here to notice, we can have a look, by the way, at the templates. We can look into this IDPS logs curator one. We can't change anything. And for example, we do see credentials here, which are referenced, but if we go into credentials, we can't see them. So the right to execute this job template was provided to us, but we can't see the execution credentials. The jobs have finished. So let's have a quick look at our SIEM curator. We check the log activity. Go into real time. And we see a lot of information, but nothing from Snort. You see the checkpoint firewall message coming every few seconds, but nothing from Snort. So what we can say now is the traffic we see is not an attack on multiple machines. It's really just our firewall blocking off here. In real world, the next step would be to analyze this traffic more, to look what packages are exactly sent, how they are looking, and so on. For the case of the demo, we just say, we find out this is not real attack, this is traffic which should be allowed, so let's whitelist it. And to avoid the need to click through complex GUIs and so on, we just enter our tower as a firewall team, and there we have a prepared template for this to whitelist the, well, we call it here attacker. And that's it. The job is running, and soon the traffic gets through. Last but not least, now all the logs are coming into Curator. This means a lot of load on Curator, a lot of information we probably don't want in our SIEM or don't need in our SIEM. And this means that in the future it will be harder to understand in all the logs coming into Curator what's going on in case we have a different attack or a different situation we want to analyze. So best is to deactivate the log sending now. And to do this, we have a prepared playbook which the analyst is allowed to execute. And this is the so-called rollback all changes. Again, this is something which cannot be edited, but we can at least execute it. And what it does is it goes to all machines and configures them back to the normal state that they are not sending any logs to anyone.